Imagine dropping a pencil. It doesn't float away, it falls straight to the ground. This happens because of gravity, a force that pulls objects toward each other. Gravity is what makes things fall and keeps us anchored to the earth. But there's so much more to this invisible force. Gravity, discovered by Sir Isaac Newton in the 17th century, is described by his law of universal gravitation. This law states that every object in the universe attracts every other object with a force that depends on their masses and the distance between them. The bigger the objects and the closer they are, the stronger the pull. So, when you're revising for your GCSEs, remember, mass and distance are key factors. Think of the Earth and the Sun. The Sun's massive gravitational pull keeps the Earth orbiting around it, providing the perfect conditions for life. This gravitational force also explains why the Moon orbits the Earth. Understanding these concepts can be useful for questions about planetary motion in your exams. Now, let's speed ahead to the 20th century and Albert Einstein. He introduced the theory of general relativity, which changed how we see gravity. Einstein explained that gravity is not just a force, but a curvature in space-time. Imagine placing a heavy ball on a trampoline. The ball creates a dip, and if you roll a marble, it spirals inward. Similarly, massive objects like stars warp the space around them, creating what we perceive as gravity. This concept can come up in higher-level questions, so grasp the idea of space-time curvature. Another cool fact is gravitational time dilation, which means time moves slower in stronger gravitational fields. For instance, time ticks slightly slower on Earth's surface compared to a satellite orbiting above. This effect is tiny but critical for technologies like GPS, which relies on precise time measurements. When studying for your exams, remember that gravity affects not just space but time too. Black holes are one of the most thrilling outcomes of gravity. They form when massive stars collapse under their own gravity, creating a point where gravity is so strong that not even light can escape. This concept can seem tricky, but focus on the idea that black holes are regions where gravity warps space-time to an extreme. Gravity isn't just theoretical, it has practical applications. It's why astronauts feel weightless in space, where gravity is much weaker than on Earth. It's also why engineers design structures to withstand gravitational forces. In your exams, you might need to apply this knowledge to real-world situations, so think about how gravity impacts everyday life and technology. So, next time you drop something or look up at the stars, think about the incredible force of gravity at work. It shapes our world and the universe beyond, and understanding it can help you ace your exams. Keep these concepts in mind, and remember to connect them to the bigger picture when you're revising and answering questions.